Good afternoon, grade 10s. Last period, long weekend ahead. It cannot get better. And I really hope that this week enticed you and got you slowly into Delphi, into practical, into coding again. So this is lesson number 4 for this week. And we are going to look at converting data types. And I've already introduced, if you paid attention yesterday in the video, I've already shown you some of it. So this is not entirely new, but we are going to apply it ourselves today, or you're going to apply it in your programming. So yes, the data type conversion is also called casting. So we converting a string into an integer or vice versa, or a floating point value, which is a real data type, to a string and vice versa. And that process is called casting. So the first one, as I said, is an integer to string. We have a string to integer. We also have a real to string, and we have a string to real. So very simple, and you should have seen that yesterday in the example. Int to string would be the function to convert this value. It is a function because int to string cannot just stand on its own. The value that we are converting, that goes into the brackets, needs to be now stored in either a variable that is of string data type, or a variable a component that is of string data type, for example an edit or a label. So it cannot stand on its own. It needs this function's result needs to be stored somewhere else. Okay, then string to integer, it's basically the same, it's just the other way around. String to int, and again in the brackets goes the value that we want to convert. Then for real to string, you might think it's real to string and string to real. No, as I said, a real number is also called a floating point number. So our conversion function is called float to string, and you've guessed it correctly, from string to real, it's called string to float. And that square bracket should not be there in the end. That is a typo. Just to refresh, a float is short for floating point number. Real numbers are floating point numbers. So there you've got it. 4 conversion or casting functions in Delphi. And we're going to apply those now in coding. So it's time for us to have a look at our textbook. So I'm literally just going to fly through this because those 4 functions are the backbone, or the information that you have to learn today. If you want to read through all of this in details, please do so. I'm not keeping you, but for the purpose of this lesson, I'm just going to highlight the most important things. So both the label and the edit are string. So enter your name, string, that's easy. No conversion necessary. However, when we want to convert a mark that was entered into an edit, which is string, and we want to do a calculation with it, with iMark we can add marks together, work out averages, work out percentages, etc. Then we need to convert it to a number that we can do calculations with. So in this case, we would read the mark out of the edit into smark. Then we can do the conversion from smark string to int to imark, and then we can display. Now obviously this is not really necessary if we just want to read the mark from here and display it in the caption. We could simply say lbl message.caption edtmark.text colon equals edtmark.text. But for the purpose of the lesson of learning how to convert, we are doing it the long way around. And just assume that we have done something to imark before we displayed it again. Okay. All right. So here we have our 4 functions, and there's a couple of examples given. Inum string to int, and you can see the single quotes around 500. That indicates that this number is actually text. So it needs to be converted in order to fit into inum. ih string to int edth.text. edth, the text property of an edit, is string value, so we have to convert it to fit into an integer. And the same counts for all the others. Let's just take one of the reals, float to string. So we have our average, which is a real, and here we have 2 real values added to each other divided by 2. Anything that has a division is of real value. Even 10 divided by 5 would be, which is 2, which is a whole number, but any division needs to be stored in a real, unless we do integral divisions. And we've done that when we did the binary to decimal and hexadecimal conversions. Then we used mot and div. Those are integral divisions. The remainder and the integral part of a division, those can be stored in integers, but a normal divide always needs to be a real data type. Okay, did you know? We've done already, we've covered. Okay, let's do activity 3.4, the guided activity. So for each of the functions below, write down the variable's value and type. So let's write this down. It definitely doesn't have to be that big. Let's do it like this. Okay, so the variable's value is 7321.42, and that is a real data type. Okay, and hence we have a float to string. Okay, let's write the next thing there. Okay, I'm not going to do all of them, you will get the point. Okay, what do we have here? We have another variable, which is 121.3, but this time it is not of real, because you can see the single quotes. So this one is string, and hence the conversion string to float. String to int 15, the variable's value would be 15, and the variable type is string. You can see the single quotes, and the last one would be an integer with a value of 112. Okay, 3.4.2 indicate whether each of the following functions has the correct or incorrect input. If the input is incorrect, provide a reason. So string to int, 1250. That is correct because of the single quote, it's string, and we're converting that to an integer. Number B, string to float. The 3 has single quotes, so it's string, so it's correct. Float to string, 10.5. That is incorrect because it has the single quotes, which means it's string. So we can't convert it from a real to a string. So we would have to remove the single quotes in order for it to be correct. Int to string, and again, it is already a string, 3 to 1, because of the single quotes. So if we would take the single quotes away, 3 to 1, we could convert that whole number to string. All right. Example 3, report casting. So on the drive, I've replaced the report card example that you have already looked in. I think it was unit 3.3. And I have converted the program so that you can actually open it with Delphi. So you are welcome and free to do that. So I'm not going to go through the example per se, but if I would bring up Delphi, I've created it in such a way that it actually runs. Let me just prove that to you. There we go. So in Delphi 10, this program is working now, and you will code obviously this button. So you have to declare variables, and then you have to do your conversion. But in the activity itself, it actually tells you step by step what you need to do. Okay, here's another guided activity, and I'm not gonna, or maybe I am. We can quickly do this together. So here's an algorithm that swaps two values from two edits around. So the algorithm itself is as follows. Store the text entered in the name component in a variable called sname. So we have to declare a variable called sname. Store the text entered in the surname component in a variable surname. So sname, we'll add that to sname, and whatever is typed into the surname will be in a variable called surname. Declare a third variable, sPlaceholder. Move the value from sname to sPlaceholder, move the value from surname to sname, and move the placeholder to surname. Because a variable or component can only contain one value at a time, we need a third one as a temporary placeholder to hold the value before we swap it. Because if I would write, remember, if I would write the value from one to the other, it copies it. It doesn't, so we need to swap. So that's why we have a third empty placeholder to store the value temporarily. All right, and then we can display the values of sname and surname on EDT name and LBL surname. Okay, I'm not so sure if that is actually correct, maybe EDT name or EDT surname, because we want to swap them in there. Okay, so now we have, now that you have a name and a surname swap algorithm, you can implement the program, in the program. So we have to create a project called name swap underscore p, create the interface, we're going to create that, create an on-click event for the swap button to swap the name and the surname, save and run the project. All right, so I'm going to open up my Delphi. We are going to close this report card. I will save it, and we will create a new project, a VCL Forms. All right, so I hope I can remember correctly. This is now I will zoom in a bit. So over here in the search button, we need a label and another label. and an edit and another edit and a swap. No, the button. Okay, let's go over there. There's all my forms. So here's a button. I will put edit 2 on this side. I will put edit 1. Let's try to do this as neat as possible. We have, the label maybe over there, and we have the label over there. Okay, so I'm just taking it down. Okay, the caption over here was called swap. The caption of this one was called, I believe, name, and here we will have surname. Now we will name them. If I can find the name over there, label LBL surname. Okay. This one we will call LBL name, EDT name. This one will be BTN swap and EDT surname. Okay, I typed it because by default, when I change the name property of one and I click on the other and I start typing, it will automatically still be in the name property. So you can see over here that all my components are named correctly according to our naming convention. We want to still empty this, so we scroll down to the text property, empty that. Sorry about the moving of the things, but that's unfortunate with the zoom in, and I want you to see what we are doing. Okay, so looks very unneat. We can maybe make this a bit smaller, move all these a bit up there. Okay, we don't really need more. Okay, so the program or the activity said that if I press this button, whatever I type in here should appear in the surname, and what I write here should appear there. So let's code it. How do we do this? We first declare our variables. Keyword var indentation s name, comma, s surname. And both of them are, and we said we need a third one, s placeholder. And let's do camel case holder, and those are all string. Okay, just for consistency, it doesn't really matter, but I will just make this a capital as well. Now, we have to initialize, enter the value from our edits into our variables. So s name is edt name.text. S surname is edt surname.text. All right, and we need a semicolon. Now we want to swap them around before we display it. So s placeholder colon equals, it doesn't really matter which way around, we just choose one. So I'm going to choose now is s name, then s edt name colon equals s surname, and then edt surname colon equals s place s dot text, and I've forgotten the text property there as well, dot text, and colon equals s placeholder. Okay, so we've done the swap. From first we've read it into our variables, then the placeholder becomes s name, the name becomes a surname, and the surname becomes our placeholder. Okay, let's see what happens if I run this. Whew, no mistakes. Here's our program. Okay, I'm going to make a mistake. I'm going to say Schultz, and here I'm going to say Thomas. Now, obviously, that's not correct. My name is Thomas, my surname is Schultz. So if I click on here now, it swaps them around. Awesome. Okay, so I hope that makes sense. So you can obviously watch this video over and over again, pause and try to create this yourself as well. I'm going to close this. I'm not going to save this. And there you have it. So now for the end, I want you to do activity 3.5 for the remainder of the lesson. You will have to create a project called School P that with a form that looks like this, and then you complete the instructions that's on there. And then the second program, you have to create a shopping list basket that looks like this. There's a spin edit component. Remember, you can use the value property selected from the spin edit. Then you already have an integer value, so no need to convert it to an integer. But if you want to display it in a label, you will have to convert it back to a string. So right over there. So the value has already an integer value there. All right, thank you guys for watching. And remember to like this video, subscribe to my channel, and leave a positive remark. There we go.